So today is week 4. It's a beautiful sunny Tuesday, our last Tuesday of September. Today's a really important class because um, we are going today to work with our models, and then we're going to connect all the pieces up. So that means our web application that we've been building over the last couple of weeks, the database, empty database that we set up at the end of class last week, we're going to connect them together. We're also going to look at deploying our entire application to the cloud using the Azure hosting platform. So we're kind of all the pieces come together. And actually, if we have a quick look in the lesson 2 learning reflection, where I asked, what is the one thing you would most like to learn? The thing that I constantly, or probably the most common thing, was database. I want to see the big picture. I want to see the database. How do we use different models? How do we connect to the database? So this was probably the most common thing people said they were most interested to learn next. So today is kind of the day where we put a lot of the learning, a lot of the MVC components and things we've been doing together. I'm just going to point out one little item here for you on Blackboard. Not a graded thing, but one thing I like to do, we're about a month in, is you'll notice a little further down in the week 4, there's a remote learning check-in. This is just a brief survey, a few questions where I'm just kind of checking in with you. How's the course going for you? And do you have any feedback for me? Are there any adjustments that you might recommend that I consider making to the course? So it's not for marks. It is anonymous, so I can see the answers, but I can't see who made the answers. So there's really just 4 questions. If you wouldn't mind taking 5 or 10 minutes sometime over the next week to just respond to the survey, that gives me a good gauge of how things are going for everybody and whether I need to make any adjustments through the course. Okay, so that item is here. So I'm not going to dedicate class time to it because we've got lots of important .NET work to do today. But that item is here, if you could please have a look at it sometime before next week's class. So today we're going to kind of do a bit of an overview about SQL Server. I know a lot of you have worked with it a little bit, but we're going to kind of look at the big picture and also see how it fits into web development. We've already kind of set up the database locally as well as on Azure. We did this at the end of class last week, but those are really empty databases. We're going to introduce a new .NET class called DB Context, which is a database connection object. We're going to plan out the database for our store. And then we're going to explore a couple of tools in Visual Studio. One is called database migrations. So what database migrations allow us to do is design model classes in Visual Studio and then auto-generate tables in our database based on those models. So it improves accuracy and it saves us time. We don't have to create the models and then manually try to create a set of corresponding tables and make sure we match everything up properly. The migrations will do that for us. We're then going to use the scaffolding tools in a little more detail. We scaffolded a view last week. This week, we're actually going to scaffold entire controllers and views. And then if we've got time, we're going to do some customization. And we'll also look at how do we deploy all this stuff to an Azure website. Okay. So lots to do today. We're going to watch just a quick video. It's an old video. It used to be on lynda.com, which became LinkedIn Learning when Microsoft bought them out. I think it's about 9 minutes, so I will pause the recording. Actually, you know what I will do? Rather than me stream the video link is right here. So the video is Intro to SQL Server. I'll put the link in the chat for you as well. So I'm going to pause the recording. As you watch the video, rather than me just say, just watch the video, here's the thing you are watching for. I want you to make a note of one good reason why we should use SQL Server. And then when you're done watching the video, just give me a little thumbs up with the WebEx reaction. And then we can chat a little bit about the video when we're done. Okay, so it's, I think, 9 minutes. I will pause the recording. Give me a thumbs up when you are done watching the video and you're back in the room. Okay? I'll see you back here in 9 minutes. We'll resume. So, my question was, give me one reason we might use SQL Server. So if you're going to have one quick takeaway from the video, what did you take away from it? Okay, that's an obvious one. Yeah, they're both Microsoft products, so it's going to integrate well with ASP.NET. Thank you, Scott. Alex says it's very reliable. Absolutely. And it's fast. Yeah, Shisato mentioned that we have this robust security model with SQL Server. Very true. Anything else? Anybody else took any of the other benefits? Yeah, that's right. We can, thanks, Gerlene, we can handle hardware issues and make sure that our data is protected. It is reliable. Yep, Manjinder says it comes with a variety of tools to perform specific tasks. Yeah, we can do reporting, we can do data analysis, we can manage security, backups, replication. So SQL Server, it's a very mature product. When I first started as a developer in the late 90s, we were using a version, I think the first version of SQL Server I had was called I remember upgrading from version 6.5 to 7. And I remember buying SQL Server 2000 and having my install CD-ROM back then. So it's been around for a long time. It sort of stood the test of time. No, Scott, you can still scaffold. Yes, you are still able to scaffold with another type of database. Yes. Good question. Sorry, lost my train of thought for a second. One of the other things about dealing with a mature product that's been around for a long time, no problem, is that we have lots of documentation. So anything you're trying to do in SQL Server is probably very well documented. One of the other reasons, he actually mentioned one other thing in the video that nobody else mentioned. He talked about web development specifically and web hosting. Did anybody catch what he said in the video in relation to web hosting? Just skip through. See if I can find, should have bookmarked. Yes, that's true. That is true, Scott. Wasn't quite what I was thinking about. Here. Let's go back. Okay, so what he's saying is many hosting companies. Oh, you can't hear it? Sorry, Manjinder. I guess the audio doesn't come through. I'll play that little piece again. Okay, so yes, it is hosted on Azure, but most other hosting companies, they really only give you two choices of the type of database. So for example, here's a hosting company that I've used for many years. They actually just merged. But if we look at their hosting, Can we even see it here? So what do they offer? Unlimited. Okay, bad example. So most hosting companies basically give you two options for database hosting. They give you MySQL and they give you SQL Server. So if you're looking for other types of databases like Oracle or DB2 or Postgres, you don't typically find those in most traditional hosting companies. Yeah, that's right, Attila. We see an awful lot of MySQL. Okay, I'm just going to catch up in the chat. Shisato, scaffolding is the code generation process that Visual Studio offers. So last week we generated a create form. That process was called scaffolding, where it built the form for us. Yes, Scott. So your entire stack, that's the idea. You have it all in one hosting plan. And typically we do so that we can manage it all together. So how popular is SQL Server? Well, so this is updated this month. So they've ranked 378 database systems. And you can see we've basically got the big three. So the big three here would be Oracle, MySQL, and SQL Server. And they sort of dwarf the popularity of all other database engines. Now, all of these, you will notice, they've all decreased quite a bit over the last year. And the reason for this is really the rise of these NoSQL databases, PostgreSQL, MongoDB, and Redis in particular. Redis, which is really used for caching, and MongoDB, which you're going to probably be working with in your JavaScript frameworks course. So you'll learn more about these. So Mongo particularly is a document, a non-relational DB. Okay, so we've kind of had a little look. Okay, haven't heard of that one, Attila. Interesting. Thanks for, so Attila's saying Elasticsearch is also another document DB. And there are a number of other ones. Azure has its own, whose name right now is escaping me as well. They have their own document DB. There's MariaDB, there's CouchDB. There are a number, and NoSQL is becoming more and more common, absolutely. Okay, so we watched video, we've kind of looked at this. So I've put these slides up on Blackboard. So a little bit of a review from last week. Pardon me. So I've given you the process of how to create a database locally. We shouldn't need to do this today because we did this at the end of class last week. So we would do this through Management Studio. We'd connect to our local server, probably using the default, which was Windows authentication. And then we would just click on our server, go to Object Explorer, and basically right-click and choose New Database. So I'm not going to repeat this process. We already did it last week. It's recorded in the video. We also went through the process of creating a database in the Azure portal, which you're going to need for your assignment. So we created a new SQL server, and we chose, this says free, I guess it should be the basic tier. We created our server name, database name, username, and password. We put them in a file. And then we needed to enable the firewall to allow our IP address in. Once we did that creation in the Azure portal, we could then connect to it through Management Studio. So I'll actually just connect into through Management Studio right now. I'm going to connect to the Azure database that I created last week. And it actually, I think I saved my credential here. So here was my global grub. And it saves my username and password that I created last week, and I can just connect to it. It opens up in this Object Explorer window, and here's my database. There are no tables in here yet. That's okay. We're going to do this today. So we've kind of done the setup already. So our next steps, before we connect our project to SQL Server, which is what we're going to do next, we need to design our data model for our store. Okay, so let's open up the project. We'll open up our Global Grub project in Visual Studio. And we'll just get it launched. So our project is running. So here's kind of the stuff we did last week. We also scaffolded. So Shisato, remember, we used scaffolding, which built this form for us. So here's where we left off. So what we need to do is spend a little time planning out our database here. Okay. So we want to build a food store. So let's start out by planning what tables are we going to need. I think we're going to need probably 5 or 6 tables in the database. So step 1 is let's list the tables. You can just create them in a spreadsheet here. So what tables, let's start out with just naming our, listing our tables. It's bigger. Okay, so what tables do we need in the database? Okay, absolutely. Yeah, we need our, okay, so we need categories, yes. I shall do it this way. Okay, so we'll have categories. We'll have customers. We'll have orders. Elizabeth, we might have employees. What we can actually do is we can kind of combine this. We can have a single users table. This will store both the employees and the customers. Okay. We're going to have products. Yep, Yulia, absolutely. We're going to need a cart table of carts. I think this is actually what we need. Okay, so now let's design these tables quickly. Here, better yet, I should probably do this properly. Let's go here. Okay, what do we want? We want a entity relationship diagram, sure. All right. So our categories table. Okay, well, we're just thinking about the structure. So Yulia, you're a little bit ahead of me. We're not thinking about the data yet. Let's just focus first maybe on the structure. Okay, so we know we're going to have category ID. What other columns do we need in the category table? So let's design the structure of the categories table. We'll have a category ID primary key. What other columns should we have here? We don't need too many. Yeah, Manjinder, I think we just need the name and the ID. So we can delete that. Okay, so there's our categories table. Our products table will have product ID. Yep, thanks Jennifer, Marcos as well. What columns do we need in the product table besides a product ID? Okay, again, yeah, we'll have a name. We'll have a price. Okay, the quantity we might have. Harshio, well, remember this is we're having it's food we're selling, yeah. So the warranty may not apply in this case. Yeah, we might have an expiration date. Yes, we may not. I guess it depends. We could have the weight. Okay. Yeah, Scott, I'm with you on that one. We could have the weight. And we definitely need a category ID. Yep, which would be our foreign key for sure. Yep. Name, price, weight, and let's also put in, whoops. Why don't we also put in a photo? Okay, now we should be able to, oh, whoops, this way. So this will tell us it's a foreign key. So we'll have a category ID. We may need to adjust this a little bit through the semester as we go, but that's fine. So now we can drag on, I think, so one. Okay, so we've got categories and products. So we've taken care of these two tables. The users I'm going to leave for now because the users table is a bit special, and the idea Visual Studio is actually going to build this table for us because when we created our authentication will come through there, because remember we added authentication to the project when we set it up, so we don't actually need to create this table. The table is going to get generated automatically. We'll look at that after. Okay, so now we've got categories and products. We now want, let's do our carts table. So we'll have a cart ID. What properties do we need in the carts table? What columns should be here? Yes, we'll have a price. Okay. So we've got a few suggestions related to products. So we need to think about this. In the shop, what's the relationship between cart and product? One product can be in how many carts? One or many? Yeah, one product can be in how many, and one cart, this is really a cart item. One cart item can have how many products? One or many? Yeah, so maybe what we want here, let's rename this. Instead of carts, to be more descriptive, We should probably call this cart items. So that way we can have a one-to-many. So in this case, then I'm just going to modify it a little bit. So we're going to have a product ID here. So if I put 3 items in my cart, I get 3 separate cart item records. So what other, yeah, we'll need quantity. That's right, Yulia. What other things do we need to know for each item in my cart? We need to know the product ID. We need to know the quantity. We need to know the price. Yep. So then let's say we don't necessarily need it in here, Yulia, because we can get the category ID through this relationship. Well, the receipt that'll come after. Right, Manjinder, that's a good question. So let's think about this. So Manjinder, you and I both want the same food. So we both put the same product in our cart. How are we going to know which cart is mine and which one is Manjinder's? Well, the cart is before the order, so we don't have an order yet. This is just as we're shopping. So Yulia, the order number will come after the checkout. Right, Alexander. So what we want in here is another foreign key, right? So we are going to have the user ID. So this way, Manjinder and I can both buy 3 of the same product at the same price, but we'll tie each cart item to our own user ID. So I'm going to add another one-to-many here, this time going from the product ID to the product ID here. And maybe I'll have to swap this around a little. There we go. Okay. So this is kind of the shopping experience part, right? We browse category, we view products, and we can put them in our carts. So now we've got the orders piece of it, right? So this is the shopping part. Now we get the orders table. We'll have a unique order ID. Well, keep in mind, these are individual items in the cart. So we can just calculate the total on the fly. We could store it in the database, Yulia, but probably not required because we can calculate it, right? We can just do the math here. Okay, Jennifer, you're saying cart item ID should go where? Okay. Well, how many cart items could one person have? One or many? Yeah, Marcos, that's right. So if I put 3 items in my cart, I'm going to have 3 records in cart item, all with my user ID. Okay, yeah, we will definitely need, in the orders, we'll need the user ID as a foreign key. So I'm going to add that. I will save this diagram and post it. So there's our user ID. What other table should we have? What other column should we have in the orders? We can't represent cart items here. Okay, yeah, Liz, I agree. We'll have a total. We definitely want the order date, which can include the time. Okay, yeah, we may be able to. Well, think about the payment. We might be able to, yeah, well, definitely. So Alex will want a bunch of those fields, right? It could be a separate table or it could be in here. It partly depends if we're allowing, for example, different billing and shipping addresses, or we're allowing multiple shipping addresses. In those cases, yes, we need an addresses table. For simplicity, yeah, we'll just have, so we'll have an address. I'll make this table quite a bit bigger. Move my foreign key down here. We'll have a city, province, postal code, phone. Yes, Julie, we could do shipping as well. I think for simplicity, we'll leave that out. We probably won't have time to deal with shipping, but you could put it in the model if you wanted to, yes. And maybe I'll just put in here like payment code, which we'll deal with later. See if I can, oops. Okay, so something like this. If we're only going to have one payment method, but yes, we could have a payment as well. Oh, yeah, customer name would probably be a good idea. Thanks, Drew. Two more columns. We'll have a first name. And a last name. I know we're a little bit out of order here. Probably makes sense to put the names first. Manjinder, we could. It's that for our purposes, we're going to use the auto-generated user table, and it doesn't have all those fields. So for our purposes, we'll store them in here. But yes, absolutely, we could do it that way. So we need one more table, right? So let's look at the relationship, right? A cart item, well, actually, I guess we'll look at it this way. So one product could be on how many orders? One or many? Yeah, right. Attila, you're ahead of me. We do need an order items, right? Because one product can be on many orders, and one order can have many products. So we've got a many to many here. So the user puts the items in their cart, but when they check out, we basically want to copy these to an order items table. With now the order, instead of the user ID, we've got the order ID, and then product ID, quantity, price. So what I'm going to do is copy this table, just for simplicity. And then I can just so we'll have an order item ID. We'll have the quantity, the price, the product ID, and the order ID. So 2 foreign keys. So product ID to product ID. And yes, I know this isn't perfect. There are other ways we could adjust it. I think for our purposes and simplicity, we're probably okay like this. So my lines don't cross. Always good. So there's kind of our ERD. So one category, many products, one product in many carts, one product in many order items, one order also in many order items. Okay, Drew, if we can, the difference is these items are in someone's cart, but they're not purchased yet, right? I can put them in my cart and I'm shopping, but that doesn't mean I've bought them. I'm going to copy them to order items only after the customer actually pays and generates an order number. So the data is similar, but it's at different parts of the process. So these are items that have not yet been purchased and might not be purchased. These are items that have been purchased. Does that make sense? Right? And these can be saved. I could put items in my cart, not check out, leave the site and come back tomorrow, and these items could still be saved along with my user account. So I could check out tomorrow. Right. Exactly. And these things can be deleted, whereas these can't. As Attila mentioned, the order items, we want a permanent record of what was bought. I can put something in my cart, but then I could take it out and not buy it. Okay, so I will save this. Let's see, I think I can export this as a PNG, and then I can upload it to Blackboard so we can reference this as our data model. Store erd.png. Sorry, Attila, you can share the version? Oh, that's cool. Sure. I will just upload this as well. So I've got an old one here. I'll just go to. Okay, great. Thanks, Attila. To view. Okay, so our diagram is here. So we can come back and refer to it. We may modify it a little bit, but this is basically what it's going to look like. So this now gives us a picture. What we're going to do when we come back is we are going to build our model classes based on this diagram. We're going to build 5 models, and those models are also going to include the relationships that we've identified here. And once we've built the models and included those relationships, we can connect our project to the database and actually use Visual Studio to build the tables in the database for us, which is kind of a cool thing. Okay, so we're going to take a break here. Let's come back in 10 minutes, and we'll start building our models.